All right, so chapter 6 focuses on conversions between measurement systems. So going, for example, from the metric system to the apothecary system, or the household system to the metric system. As the metric system becomes more widely used, hopefully the need to convert will decrease over time. Hopefully the United States will move more towards the metric system. The apothecary system definitely I see being phased out in the future. And then maybe in the distant future, the household system as well. And that's just because the metric system is the most accurate system, and it's going to be used worldwide. So very easy to use with medications. So once again, we're going to be doing ratio and proportion and dimensional analysis. So I'll go through some examples of that again. Usually when we're going from system to system, you may have to do dimensional analysis if you have more than one conversion factor. So I really do want you to be comfortable with both of these processes. Like I said in chapter 5, they're going to carry out with us through the rest of the book. Since we're not too familiar with the apothecary system, here's just some, equivalents to get you acquainted here. 1 gram is approximately 1 teaspoon, which is the same thing as 5 milliliters. And then the ounce in the apothecary system is very similar to the ounce in the household system. And 1 ounce is equal to 30 milliliters. And then 1 grain is going to be equal to a range of 60 to 65 milligrams. Now that's going to depend on what drug that we are looking at. And I'm going to show you a table in your book here in just a little bit to focus on what I mean by that exactly. Most conversions are going to be between metric and household system, the metric and the household system when we're dealing with volume. So like I said earlier, if you're going from teaspoons or tablespoons into milliliters, you'll have to do that a lot for those written oral solutions. Length, we use that occasionally, and then mass, we also, once again, use that occasionally if we're talking about a larger weight or a larger mass. But most of the time, we're talking about weights of active ingredients, so things like milligrams and micrograms. So we're just going to get right into some examples here from the lecture notes worksheet. I'll try to go through several of these, just enough to where I feel comfortable that you guys should be able to do the rest on your own. So let's take a look at, let's do the second one here. 16 tablespoons is how many ounces? Well, use your conversion chart here. So we're going to go from ounces to tablespoons. So it says 1 ounce is equal to 2 tablespoons. So 1 ounce equals 2 tablespoons. Now I'm going to do this with ratio and proportion first because I only have, one conversion factor. So ratio and proportion is setting two fractions equal to each other. So 1 ounce over 2 tablespoons equals, now remember when we see that equal sign, our units have to be equal. So ounces on top, tablespoon on bottom. I'm looking for how many ounces are in 16 tablespoons. So when I'm solving for x, we're going to cross multiply. So 2x equals 16. Now I can divide by 2, x equals 8. So now 8 is less than 10, so we need to leave that in a Roman numeral. So 5, 6, 7, 8. So that was ratio and proportion. Now I'm going to do the same exact problem using dimensional analysis here. So let me adjust my camera here. Okay, so same problem here. I want to use dimensional analysis. So start with what we want. So we are looking for ounces. Follow that with an equal sign and make that to where that unit is on in the numerator of your first fraction. So once again, we knew that 1 ounce is equal to 2 tablespoons. Now make your second fraction have this unit in the numerator. So now I know that I'm looking for 16 tablespoons here. That is just by itself, so we can keep that over 1. My tablespoons cancel, and now we can solve. So 1 times 16 is 16, 2 times 1 is 2, and once again, we're left with 8 ounces. So if we're writing that in the apothecary, just like we did here, symbol first, and then 8 in Roman numerals. So if you want to, analyze the difference between these two processes, now would be a good spot to pause the video and really make sure that you understand ratio and proportion versus dimensional analysis, and make sure you're confident that you can use both of these processes to solve for any of these problems. Okay, so I would like you to turn in your book to page 107, and we're going to be looking at table 6.2. If you have this handout, it's also on the second page. I just printed it out here. So this is that table that I was talking about earlier when we are converting grains into milligrams. So 1 grain equals 60 to 65 milligrams depending on the drug, okay? So if they do not specify the drug, we're going to use 1 grain equals 60 milligrams. If they specify the drug, use this chart, okay? So for example, this problem here says we're looking for codeine. We're going from grains to milligrams. So codeine, it says 60 milligrams is 1 grain. So that's what we want to use for this problem. So if 1 grain equals 60 milligrams, we want to figure out how many milligrams are in 3/4 of a grain. So once again, I'm going to do this both ways. I'm going to start out with ratio and proportion, then I'll do dimensional analysis. So ratio and proportion, I know that 1 grain is equal to 60 milligrams, and I'm going to set that equal to a fraction that has those units equal. So I'm looking for 3/4 of a grain, so that is going to stay on top. That whole fraction's on top. And I'm solving for milligrams. Now, this looks a little weird. It's a fraction within a fraction. So the easiest way to get rid of this would be to turn that into a decimal. So how do we turn a fraction into a decimal? Well, we look at it as a division problem. So 3 divided by 4. So if you aren't sure how to convert that, just divide. 3 divided by 4. That would actually give us 0.75. Now that looks a little bit better, so we can actually solve this for x now. So cross multiply, I have 1x, and then I'm going to take 60 times 0.75. So that gives me 45. Now divide by 1, which anything divided by 1 is just itself. So 3/4 of a grain equals 45 milligrams. Now, let's do this using dimensional analysis. So dimensional analysis, start with the unit you're looking for. We're looking for milligrams. Follow it with an equal sign. Make sure that unit is on top. Start with what we know. We know that 1 grain is 60 milligrams. So 60 milligrams on top, 1 grain on the bottom. Follow that with a fraction that has this unit on top. So we know that we're looking for, so we've already used our conversion factor. We're looking for 3/4 of a grain. And that's by itself over here. So we can just put that over 1. So my grains cancel. I'm left with milligram. Now I can solve. So once again, if it's easier for you, turn this into a decimal. So 3 divided by 4 gives us 0.75. And then 60 times 0.75, once again, is 45. 1 times 1 is just 1. So I'm left with 45 milligrams. So same answer, 2 different ways to get there. All right, let's look at this example here. 14 quarts equals how many liters? Well, let's look at our conversion chart here. I see that 1 quart equals 960 milliliters. So we could use that. But that still doesn't get me to liters. So now I want to know, how do I get from milliliters to liters? Well, 1 liter is equal to 1,000 milliliters. Common conversion that you should really focus on memorizing there. If you're not sure where to find that, it is in table 6.3. 1 liter is 1,000 milliliters. So in this case, I have 2 conversion factors, so I cannot use ratio and proportion. It's just not going to work. We can't just set quarts equal quarts over liters and solve for that, solve for x, okay? So I have to use dimensional analysis in this case. So dimensional analysis, start with what we are looking for, which is liters. Follow it with an equal sign and keep that on top of the first fraction. So what do I know about liters? I know that 1 liter is equal to 1,000 milliliters. So I've used that one now. Second fraction needs to have milliliters in the top. Well, all I know here is 960 milliliters is equal to 1 quart. So I've used that second one. Now my mils are canceling out here, but I can see that I'm left with liters over quarts. I only want to be left with liters. So I need to get rid of this quart. So I need to put quart in the numerator of this fraction here. The only thing I have left is this 14 quarts, which it is by itself. So we're just going to put that over 1. Now my quarts can cancel out and we can solve. So we have 960 times 14. I get 13,440. And then 1,000 times 1 times 1 is just 1,000. So divide that by 1,000. We get 13.44 liters. I'm going to go through one more example with these grains to milligrams because I feel like this is where students tend to struggle the most. So remember, if you're going from grains to milligrams and they specify a drug, you got to look at that table. So we got to look and see nitroglycerin. It says 60 milligrams is 1 grain. So 1 grain equals 60 milligrams. I'm going to use ratio and proportion because I can see that it's an even equivalent here. So if I know 1 grain equals 60 milligrams, set that equal to a fraction that has grains on top, milligrams on bottom. I know I have 1/150th grain, and I'm looking for milligrams. So this looks a little odd again, so we need to convert this into a decimal. So we take 1 divided by 150. 1 divided by 150 gives us 0.006, and that is repeating. So at this step, since I know that that's a decimal and it's repeating, I would leave that in my calculator and go ahead and just multiply that by 60. So that gives me roughly 0.4. And now I can cross multiply this way, equals 1x. So then x is equal to 0.4 milligrams there.